Welcome back, guys. Today we'll be doing a CAPE Unit 1 question. It's coming from 2019. Let's get started. Now, here we have a question. Let A equal x such that x is an element of a real number where x is greater than or equal to 1. A function f is such that A maps onto R, where R represents real numbers, is defined as f of x equal x squared minus x. Show that f is a one-to-one function. So in order to show that it's one-to-one, then we have to show that f of x1 is equal to f of x2. So we're going to choose points x1 and x2, and when we substitute, they should be equal. If they're not equal, then we consider it not to be one-to-one. So when I substitute f of x1, it must be equal to f of x2 for it to be one-to-one. So I'll be substituting x1 into the function x squared minus x. Now, when we substitute, if we have it being equal, it is considered to be one-to-one. So that's what we're going to do. So substituting x1 into the function, replacing x squared minus x with x1, I will have x1 squared minus x1. Then I replace x with x2. So what I will have is x2 all square minus x2. So we're trying to show that it's one-to-one. So we're going to equate them to be equal, then simplify to see if we can get a one-to-one relation. So equating these to be equal, we are going to see if we have a one-to-one relation. So for f of x1, I replace it with x1 squared minus x1, and it's equal to x squared. Well, you're going to have x2 all square minus x2. Now our aim is to get it to be one-to-one, if it's possible. So what I will be doing is carrying the x1 square over the equal sign and the minus x2 over the other side, which is the left-hand side. So what do I have? I will have positive x2 minus x1 is equal to, carrying this over, so I will have x2 square minus x1 square. Now, this that I have here can be factorized using difference of two square. If you don't remember what is difference of two squares, like a perfect square. So what I'll be doing is using difference of two square to factorize what I have. So applying difference of two square, I will have x2 minus x1 times x2 plus x1. So that's applying difference of two squares, like a perfect square. Now I can write this as x1 plus x2 or x2 plus x1. It's the same thing because it's plus. That's why I have x1 plus x2, but it can be x2 plus x1. Same thing. Now I'm going to carry this over the equal sign. So having this over the equal sign, I will have x2 minus x1. So I'm going to have this in brackets. So I have x2 minus x1 minus the product that I have here. So x2 minus x1 times, remember, x1 plus x2 is the same thing as x2 plus x1. It's the same thing, so don't think it's different. And it's equal to 0 after carrying it over the equal sign. Now, my next step is to have a bracket because I will be factoring out x2 minus x1 outside of this rectangular bracket. So when I factor out x2 minus x1 outside, what am I left with? Inside my bracket, I'll put a 1 in this position, don't just leave it empty, minus, then I'll have my next bracket, which some persons will have x2 plus x1, but in my case, I have x1 plus x2, and you can have it whichever way you prefer. It's the same thing. Now, what I'll be doing next is showing you that we're going to solve. So it's like when we were factorizing a quadratic, we know that when we have this part where we're going to solve, we equate each of the brackets to be equal to 0. So it's the same scenario here. We're going to equate each of the brackets, so x2 minus x1 to be equal to 0. Then we solve, so we carry the x1 over the equal sign. So I have x2 is equal to x1. Then our rectangular bracket section, I'm going to equate it to be equal to 0. So all of what is in the rectangular bracket, we equate it to be equal to 0. Then I will just go ahead and expand, so clearing the bracket, so distributed the minus sign, so everything changed to negative. And then I will go ahead and carry the x2 over the equal sign, so it becomes positive x2. So this is saying x2 is equal to 1 minus x1. Now what is that telling me? Remember, we were given a condition in the first part that x is an element of a real number where x is greater than or equal to 1. So that means x1 and x2, they both have to be greater than or equal to 1. It's coming from here. So if x is 1, 1 minus 1 is 0. Doesn't satisfy that x greater than or equal to greater than 1. Same case, if I replace x1 to be 5, I'll get a negative number. So what this is saying is that I will not be able to satisfy the condition above. So since it's impossible for me to satisfy the condition, for this part, we say it's not possible based on the condition that is given that x1 and x2 must be greater than or equal to 1. That's not possible. However, over this side, I have x2 is equal to x1, and for it to be 1 to 1, this is what we need to have. So this is the answer. This is what shows that it is indeed 1 to 1. Now, here we have f of x is equal to 3x plus 1 and g of x equal e to the 3x. First, we're going to determine f inverse. So to find f of inverse, the first thing that we do is change f of x to y. That's the first thing that we do. So we change this to y. So I have y is equal to 3x plus 1. Then I interchange x for y and y for x. So what I'll have is x is equal to 3y plus 1. After doing this, we're going to make y the subject. So we carry the 1 over the equal sign. So I have x minus 1 equals 3y. Then I divide both sides by 3. This cancels. So what I have here is y is equal to x minus 1 over 3. Now, y is the same thing as f inverse. So the inverse function is x minus 1 over 3. That's it. Now for this, I am going to do a composite function. We're substituting the function g into the inverse function that I have above. Now g is e to the 3x. So what I will be doing is just replacing the x in the inverse function with e to the 3x. So what I'll have is replacing x with e to the 3x that I have here. So I will have x minus 1 over 3, that's the inverse function. And I'm replacing x with the e to the 3x that I have here. So the answer for f inverse of g is equal to e to the power 3x minus 1 over 3. And that's it. For the next equation, we are going to solve using different techniques. Now this 81 to the power x, I will be rewriting it this. Now 81 to the power x, first 81 is the same thing as 9 squared. So if I have 81 to the power x, it is the same thing as we change the 81 to 9 squared, then I have the x attached to it. So that's what I'm going to do. I am going to change the denominator for where I have the 81 to the power x being replaced with 9 to the 2x. So that's what I am going to write here, 4 over 9 to the 2x. And it's equal to 0. Now, I want to get rid of the fraction, so I am going to multiply the entire equation by 9 to the 2x. So multiplying, I'll have 3 times 9 to the 2x. Then I multiply minus 4 over 9x by 9 to the 2x. Now multiplying this 9 to the 2x times the fraction, which is, let's forget about the sign for now, 4 over 9x. We are applying laws of indices. Because the 9 to the power x in the denominator, we're going to write the base once and subtract the power. So we have 2x minus x, and that will give me 9 to the power x. So that's what I'm going to have here. So I write the 4 and then 9 to the power x. That's what the results will have. Now I'll also multiply the third term. So I'll multiply the first and the second. Now it's a third term that I'll multiply by 9 to the 2x. So multiplying it, it will cancel. So I will be left with just minus 4 equal 0. Now, where I have 9 to the 2x, I am going to manipulate this. If I have 2 to the 6, 2 to the 6 is the same thing as 2 times 3 in the power section. So 6 is the same thing as 2 times 3. And I can also write it as 3 times 2. They're saying 2 to the 6 still. Now I could also rewrite this in a different form where I have 2 to the 2 inside the bracket, then a 3 outside, and it is still saying 2 to the 6. I can also rearrange the power, so I have the 3 inside and the 2 outside. So that means I will have 2 to the 3 inside my bracket, and then outside the bracket I will have the 2. So the arrangements that I've shown are the same 2 to the 6. That's what I'm going to do here with 9 to the 2x. I can rewrite 9 to the power 2x. So I have 9 to the power 2x. And what I'll do is carry the 2 on the outside. So I will have 9 to the power x, and that will be inside the bracket, while I'll have the 2 on the outside, and it is the same thing as 9 to the 2x. I just shown with numbers. 3 times 2 and 2 times 3. Same thing. So 9 to the power 2x, it's the same thing as 9 to the x all square. So I will replace here with 3 open bracket 9 to the power x close bracket all square, and then everything else remains as is. So now we're going to let y represent 9 to the x. So replacing 9 to the x here, I will have 3y squared minus, replace the 9 to the x with y, so I have minus 4y minus 4 equals 0. Now this is where we factorize. By right, if you don't like to factorize, you can use a formula, but for me, I'm going to factorize. I multiply 3 times negative 4 at the end, that gives me negative 12, but add to give me minus 4. So we need the two factors. So the two factors will be minus 6 and 2, because minus 6 times 2 gives us negative 12, and minus 6 plus 2, that gives me negative 4. So the next step is to replace the center with the factors. So I have minus 6y plus 2y minus 4 equals 0. Then I group. So I have the first two in one group and the next two in another group. So what can I factor out of the first? It's 3y. And when I factor out 3y, I'm left with y minus 2. Then the next bracket, I will be factoring out the number 2, positive 2. And when I factor out positive 2, I'll be left with y minus 2. So what do I have? I have 3y plus 2, and I have been multiplied by y minus 2 equals 0. Now I'm solving. So I'll be equating each of these brackets to be equal to 0. So I have 3y plus 2 equals 0. So solving for this, I carry the 2 over the equal sign. So we have 3y equal negative 2. Then we divide both sides by 3. So y is equal to minus 2 over 3. Now, the next part, I equate it to be equal to 0. Y minus 2 equals 0. Carrying the 2 over the equal sign, so I have y is equal to positive 2. So the solution that I have here is y equal minus 2 over 3 and y equal 2, but y is actually 9 to the power x. So where I have y equal minus 2 over 3, I replace y with 9 to the power x. So I will have 9 to the power x equal minus 2 over 3. But when you have negative, you can't do anything about this. So it's no solution because you can't log and you cannot rewrite it in the common base with a common base. So there's no solution for this one. For y equal 2, I'll replace y to be 9 to the power x, and then it's equal to 2. Now what I can do is log both sides. So I will log both sides, and then we will carry the x in front of the log. So I will have x log 9 is equal to log 2. So divide both sides by log 9. So we divide both sides by log 9. The log 9's cancel, so what I will have now is x is equal to log 2 over log 9, which we can work out, but I'm going to leave it as it is. So that's it. Our final question states, let the roots of the equation 2x cubed minus 5x cubed plus 4x plus 6 equals 0. State the values of alpha, beta plus gamma, alpha beta plus alpha gamma plus beta gamma, and alpha beta gamma. Now, alpha plus beta plus gamma, we are going to use the above to find the answer. So it will be negative minus 5 over 2. So negative and negative, that's positive. So I'll have 5 over 2. Now to find out what is alpha beta plus alpha gamma plus beta gamma, it is equal to the coefficient of x, which is 4, over the coefficient of x cubed, which is 2. So I will have 4 over 2, which is the same thing as 2. Now alpha times beta times gamma is equal to minus the last number, which is a constant, over the coefficient of x cubed, which is 2. So minus 6 over 2 is negative 3. The next question, hence or otherwise determine the equation with the roots alpha, beta, gamma. Now, roots that have alpha square, beta square, and gamma square has the general form that I have here. So this is a general form for a cubic function that has roots alpha square, beta square, and gamma square. So the coefficient of x square is alpha square plus beta square plus gamma square. And the coefficient of x will be alpha beta all square plus alpha gamma all square plus beta gamma all square. So this represents the coefficient of x. And the final one represents a constant, where the constant will be plus alpha beta gamma all square, or alpha square plus beta square plus gamma square. So looking at the cubic, I need to find out what is alpha beta gamma square. So that's the first thing that I'm going to find. Now, I had already found out what is alpha beta gamma. That's negative 3. So therefore, alpha beta gamma all square will be minus 3 all square, and that will give me 9. The next one that I need to find is alpha beta all square plus alpha gamma all square plus beta gamma all square. So while I write this, we're going to use the part that's stated note. So this expression is equal to alpha beta plus alpha gamma plus beta gamma all square minus 2 alpha beta gamma times alpha beta plus beta plus gamma. So I'll be using that. So this part I've already done, it's equal to 2. So replacing here with 2, I will have this being replaced with 2. So I have 2 square minus 2 times alpha beta gamma was already found. That is negative 3. So replace here with minus 3. And then I have alpha plus beta plus gamma. That is the same thing as 5 over 2. So I'll have my 5 over 2 here. Just to calculate this, so I have 2 squared, that's 4. And here, there will be a positive sign because minus times minus will be positive. Now the 2 times 3 will be 6. Then I multiply by 5 over 2. But the 2 in the denominator, we can cancel it. So 2 into 6 goes 3 times. So 3 times 5 gives me 15. So 4 plus 50, that's 19. The next part, where I have alpha square plus beta square plus gamma square is equal to the following. I am going to replace inside the bracket. I know what is alpha plus beta plus gamma, right? So alpha square plus beta square is equal to, I'll replace alpha plus beta plus gamma with what was found in the previous question, which is part 1. So replacing here with 5 over 2. So I will have 5 over 2 all square minus 2 times alpha beta plus alpha gamma plus beta gamma, that was found to be 2. So I replace here to be 2. Then I have this being square, so I have 25 over 4 minus 2 times 2, that gives me 4. Now I'm going to find the LCM. You don't have to, but I'm going to do that. The LCM is 4, so 4 into 4 goes 1 time. So 1 times 25, that gives me 25. Minus 1 into 4 goes 4 times, so 4 times 4, that gives me 16. So 25 minus 16, that gives me 9. So this is 9 over 4. So the next step is just to substitute this in the cubic form. So for the cubic form, I am going to replace here with 9 over 4. So I will have 9 over 4 x squared, because we found alpha squared plus beta squared plus gamma squared to be 9 over 4. So that's why I'm going to replace here to be 9 over 4. The next part, I found it to be 19, so I will be replacing the coefficient of x to be 19 that I found here. So I'll have 19x. And the final part, I will replace alpha times beta times gamma all square is the same thing as 9. So this is the equation, and we can rewrite it by multiplying all of this by 4. So multiplying each term by 4, I can get rid of the 9 over 4 that I have here. So multiplying it by 4, this is what I'll have. 4 times x cubed, that's 4x cubed. And then minus 9 over 4 times 4. The 4's would cancel, so I'll have minus 9x squared. Then 19x times 4, that will give me positive 76x. And 9 times 4, that's 36 equal 0. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.